Okay. So I think we're going to be moving over to show and tell.
And we have the Nito robot over here on my left, near the wall here. And let's see, I need to scroll over. Now I bring my map over, and let me okay, regardless, wherever that is, I'm going to make that my goal. I press, drag, and release, and the robot shall navigate there. So hold the robot navigator.
Go robot.
He says optimistically. What do we see here? When you see the green, that's the path planning lines. So that's my target. Let me try to shift that map over so we get a better look. Let's see. Let's see what's going on with the robot. Is he doing the whirling dervish yet? That's actually a good sign.
No.
Let's see here.
Cam?
Yes.
I've heard some people asking about the picture of the map. Can you talk briefly about how you got that? Because not everybody's going to be aware of that.
Okay. This is RViz. And thank you, Mark. RViz is the ROS visualizer. And I shall, let's see here. What's the trick? It allows you to map the environment. Basically, we were talking earlier about G-mapping. And G-mapping is mapping the environment, and then you save that map. And let's see, I need to get, there's the 2D nav goal. Okay, bear with me. 2D nav goal, I'm going to move this over. And I'm going to try to give him a little easier goal. Unfortunately, it's always out of range. So I'm going to click here anyways.
That is this.
So this is RViz. This is the ROS visualization tool. Okay, and ROS gives us several things, including standardized mapping, standardized navigation, standardized messaging, standardized visualization. Standardized logging tools, standardized means of distribution through GitHub. So, it's giving us all these wonderful things. This software is based on the software from PR2. I'm playing around with software that's based on a robot that cost $250,000, and it scales. Okay. And yeah, it's because the path, there was an obstacle in front of it that never cleared out, so the path planning wasn't good and it just sat there. And obviously that has to do with being in demo mode here. But here we go, it's seeing the path. You see the path planning lines, the robot's going. And oh, here's something. I shall 2D nav and locate myself in front of the podium. Facing forward. No hands, see? Dun, 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 Hi, Peter, how you doing?
Where's the book?
Hey!
Where's the book?
All right. So here he comes in front of the podium.
You can't see the strings on him either.
Pardon?
You can't see the strings either.
Yeah, it's amazing what you can do in CGI these days. So the robot, you see the path planning lines and so forth. When it gets closer, it gets stronger, you get more lines and that kind of thing. So too, this is a 3D map. So I mean, you can swivel around. The LiDAR is like 4 inches above, and so here you see the LiDAR scans. Okay. And so finally, we shall exit stage right. All right, here we go. Point, press, drag, mouse up, and here he's navigating to my right-hand corner pocket here. Excited, huh?
Question.
Shoot.
What's the LiDAR sensor that you're using?
This is the Nito robot vacuum cleaner. It basically has a laser and an imager, and it uses trigonometry to discern the distance of the obstacle. It spins at 5 hertz. It takes 360 snapshots per cycle. And again, the bot vac, I can't say enough about the bot vac being a great Ross trainer, as well as a floor cleaner.
I think he decided to go
He's doing an alternative path. Look at that.
It was his path.
He's worked it out.
All right. You know these robots. Anyways, so there's Ross nodes for the bot vac as well as the LiDAR itself. So, you know. Any other questions?
Sure. What are the colors mean on the map?
Okay, the yellow is the boundary, and that's actually, you know, in the mapping and the G mapping. The blue around it is the inflated obstacle, and that's variable. You can vary that so the robot, you know, has an easier time or harder time, you know, going through a threshold. And then the light blue, or the local cost map, that's called, and that's the LiDAR scan there. And hopefully it lines up with the map, and that's how the robot localizes and so forth.
But the light blue is being taken in real time right now, but the stuff that's dark green with the yellow in the middle, that was because he drove around the room first to let it sort of get a map, then he saved that. So you're seeing 2 maps in one, real time and a saved one.
Okay.
And the reason it's taking so long is because it's doing AML.
Is that you complaining, Alan?
No, I'm asking why it does the extra.
Yeah.
No,
well, I do notice that it's interesting. Somebody mentions it's these guys out here, and they're much more about this than I do. Steve, okay, is he higher? Anyways, it does radius mic. You see it drive on the left wheel and then the right wheel. You know, it's really got to be on target for both wheels to go forward. So it's doing things with, you know, radiuses. It's almost like it's walking or something. I don't know. It parked where it was supposed to. Thank you.
To be honest, the number of times Camp has tried to do the demo and fails, but he's been succeeding every time.
Hey, man.
Got it down. Okay. And it's our own fault for not bringing more robots.
Hi everyone. So, me and Kent here, my name's Tyson. We're from Scans. We're a small sensor development company that's working on a new low-cost scanning LiDAR sensor. This is great for, I think, this group because you know, something that has been in need for quite some time now. You know, we're both robotics enthusiasts. We've been working with robots for a long time. It's kind of our career, and we decided about 2 years ago that we were going to make our own LiDAR sensor. We saw that there was a big need in the market, and we've been trying ever since. And so now we've come up with something called Sweep. It's this little guy. So this little guy is kind of similar to what you saw in that little vacuum there, except that it works outside, can work in full sunlight environments, and has a range of around 40 meters, which compared to about 6 meters on that little guy is quite a bit more.
Can it clean floors?
You could, yeah. Well, could be used on that. And what you see on the right here is a little development unit. It's one of our sort of ugly versions.
So this is our viz. This is what Camp was using before to visualize. And so we have a Ross driver for Sweep that's ready to go. Yeah, question? Oh, okay, these are just yeah, so this is our room right now. I'm having a hard time understanding my orientation here.
Yeah, it's so it's a TV plane sensor, same as the on the needle there. And so it's taking about 500 samples per second right now.
And can I get one?
So you can kind of see it out there, yeah. So we actually have a Kickstarter going right now.
Yeah.
It's got about 11 days left. So if you check out, if you look for a sweep on Kickstarter, you'll find it.
The NASA contest is in June.
Yeah, so a lot of people have been asking us about, can I get like an early beta version? We have a few, but they're all out with testers right now. The delivery date for the Kickstarter is in November of this year.
And the price is $245 right now.
Right, yeah, so we've only got a few left at the bargain price of $245, and it goes up to $245.
Yeah,
$45?
That's right.
Is it time of flight?
Yeah, it's time of flight.
Yeah, so some of the big differences between this and what you've seen on the Nito there is that, so it's a true time of flight sensor. That's what gives us the outdoor range and light immunity. That sort of, this is using also some newer technology that allows us to filter out noise much better than all the other traditional LiDAR out there. This allows us to use lower cost and kind of lower power components, which is part of the reason why we're able to cut the price way down. Sorry, do you have a question?
40 meters for what kind of a target?
So that's about 20% reflectivity target. It's kind of our threshold. Obviously, so we've actually seen even better results with like 90% reflectivity targets, but you can't really expect that in real life too often.
What's the resolution?
Infrared, yeah, so it's about a 905 nanometer laser light source. Which is, yes, invisible to the eye, but the power is low enough that it's class 1 and eye safe.
How does it compare to something already commercially out there, like the SIP 40 meter?
Yeah, well, for one, it's about a tenth the price.
Yeah.
As far as performance, it's not as fast, of course.
360 degrees? Or?
Full 360 degrees, yeah. So that's one big plus, especially for things like drones and.
What's the resolution?
So, like I said, 500 hertz is the sampler rate, and then you can scan it at between actually we're going to say between 1 and 10 hertz. So you can kind of do the math there, up to around 500 samples per revolution.
Yeah, you can get to sub-degree resolution though.
Right. Yeah, so if you wanted to do like a static scan of a room, so one of the things we've been playing around recently is with doing full 3D scans. We're working on a second stage rotation. A second rotation stage allows it to slowly scan an environment, make a full 3D map of the space, and then for that purpose we're working on making it even slower so you can really get a lot of data.
So what's the interface to it? What does it give you back?
So the basics are UART. Then we've also got providing a UART to a USB adapter. So just high-speed serial. Yeah. And we're going to be providing SDKs for all the major languages.
I have two questions. One was, what is the accuracy of the reading?
Yeah, so it's about 1 to 2% of the measured distance.
The other question was, is there a quality of signal output?
There is.
Did I detect a mirror with it?
Yeah, so we're still playing around with that functionality, but there is a signal strength output. Yeah. Any other questions?
How's the short range scan distance? Like, what's the minimum distance you can see?
Yeah, so really it's about a meter. It's less than that. We're trying to work on some more noise issues. Yeah.
But it's really it's a signal strength issue. If you're looking really close, you get almost too much signal back, and you're messes you up a little bit. But
I was just wondering if you could just walk in front of it so I could see something move.
Yeah.
Right, be the model.
And where is it?
So right now it's operating around 2.5 hertz, so it's not going to look super fast.
I mean, you can speed it up if you're really trying to do.
Right, and this visualizer kind of forces it to be centered on the sensor, so it's kind of hard to see, but there's dots way back in the back of the room that are like too small to see in the view.
Yeah, I can't see the window like this.
What was the name again?
Yeah, it's getting in the back of the room, no problem.
Name is Scans. Sorry, company name is Scans. This product name is Sweep.
Can you spell it?
Scans is SCANSE. That's a scan sense.
Yeah.
Yeah.
That goes into look.
Yeah.
What is the power consumption, and does that change the resolution?
So power consumption is a little bit less than a watt on average. So very low compared to all of our competitors, which is great for like drones and other mobile robots. It does change slightly with the scan rate, but only a couple of percent. Yeah.
Very low. How immune to vibration is it?
So it's pretty sturdy. It's really designed for moving mobile robot applications. Of course, it's got a head that spins, so if your robot's doing lots of spinning, that can affect it some. If your robot's mostly doing X, Y, Z movements, at least and not too jerky, then you shouldn't have a problem. So the head is dynamically balanced. So, as long as it's being moved in X, Y, Z motions, it's not like won't affect it.
Do you have?
Yeah.
Are there slip rings in there to transmit
So
the signal?
yeah, so the version we're selling Kickstarter right now is sort of our first edition, getting out there, getting people excited about it. And so it does have slip ring. It's like we're trying to get there as fast as possible. It does have a slip ring. Our next version we're working on currently, we're trying to get rid of that. So this will have somewhat of a limited lifespan just because of the slip ring. That's the one wearable component. Yeah, about a year lifespan is roughly what we're calculating.
If you're running it continuously, so.
Right. Yeah. If you're doing like a drone or something, that could be like 10 years. Right. Well, yeah, a couple hours a day or something. Yeah.
What sort of, have you put this on any like ground-based mobile robots? Like what sort of terrain have you put on?
So we've done a lot of testing outdoors, definitely. We haven't had time to do a whole lot of full-on mobile robot applications yet. So we do have a couple of testers that are doing that right now. Mostly for like last mile delivery and ground robot applications. So I think that's going to be a great application for the sensor. So it's doing great in full sunlight outdoor applications.
No problem with like vibrations, or how is it subject to vibration? How does it hold up?
Yeah, it's doing pretty well. Yeah. We're still obviously, this is the beta set of sensors. It's not 100% done yet. So the plan is to go into production in about 2 months and deliver in around November timeframe. Yeah.
So it gives you a heading and a distance, is that right?
Yeah, so angle and distance and signal strength in each packet that you get.
What kind of control do you have over the direction of it?
So
is it always spinning, or can you?
Right. So.
Is it in a range, or?
Yeah, the way it's really designed to be used is as a continuous rotation sensor. We've been talking about maybe making it be able to scan a little bit. If it's going to be if you're going to try to use it as a,
it'd be more wear to go back to it. I'm just curious.
Not necessarily more aware, just it imparts vibration in whatever base you got it attached to. So if you're on a drone, that could actually be detrimental. There are definitely applications though where you want to just like scan a box or some kind of sort of spiral thing, and we're probably not going to do that with this generation of the product, but maybe in the future.
How fast does the motor spin?
So between 1 and 10 hertz is what we're allowing it to, giving you. That'll be configurable in settings. So we've actually got our own visualizer as well that'll give you like a menu of settings you can program it with quickly.
10 full cycles a second and 500 samples per second.
Exactly. That's the fastest you want to go at. And that only gives you 50 samples per revolution, which is pretty coarse. It might be enough for quick object avoidance applications, but wouldn't want to try to use that to map any obstacles.
Does it work tilted? Run it upside down? And
Yeah.
horizontally?
Yeah, so that's the nice thing about it being, the head being, you know, dynamically balanced is it really doesn't matter what orientation it's in. Yeah.
All right. Thank you.
Well, thank you very much.
It's not a robot. It's a very tiny sensor. I work for Broadcom, and we got a whole bunch of these, what they call Wicked Sense. It's a Bluetooth device with several MEMS sensors, accelerometer, magnetometer, gyroscope, humidity and temperature sensor, LED, and a little buzzer, and then ARM Core M3, ARM Cortex M3 processor that runs the whole thing, and so weighs, I don't know, about 2 ounces or something, plus CR032 coin battery if you're not running it off of USB power. I'm still playing with it. I got the IDE running and everything, but haven't written any applications for it.
And it's manufactured by Broadcom?
Yes. And about how much is it?
I actually don't know, because they gave them away to us. But I don't think it's terribly expensive.
Guys still have some sunspots, you know.
Anyway, I just thought it was cute and probably useful for some kind of robot project. But
what was the name, or are they going to use that name when they market it?
Yes, there's a whole series of Bluetooth development kits with the software and so forth that goes with it. And this particular thing comes in a little plastic case. I took the plastic case off, and they call it Wicked Sense. But there's like Wicked Wi-Fi, WICED, no K. And so anyway.
Thank you very much. Tell us as you make more progress.
Sure.
Post it on the mailing list.
Yes, please.
Okay.
Okay, that's going to be it for show and tell.